All right, the last question here. 2x minus 1 over 4 minus 4x over 3 equals 2x minus 3 over 2. We got to get a common denominator. And they have to be a number that they all can be divided by and would spit out a nice whole number or integer. So like 3 and 2, for instance, 6 would work because 6 can be divided by 2 and 6 can be divided by 3, but 6 can't be divided by 4. So one of the ways you could do it is to go 4 times 3 times 2. So 4 times 3 is 12. 12 times 2 is 24. Common denominator of 24. So can 24 be divided by 2? Yep, 12. Can 24 be divided by 3? Yep, 8. Can 24 be divided by 4? Yep, 6. So that would work. However, I think 12 might work. So you can always multiply all of the denominators to get a common one, but there are sometimes lower ones. You don't have to do a lower one, but I think in this case the best one to choose would be 12 just because it's the smaller number. So on the on the right, we're going to start with a 2 there. We're going to need to multiply. To get to 12, we're going to go 6. But remember, on the top, you're going to need to put brackets on it because there's two things that need to be multiplied by 6. The middle one here, 3, that can be times by 4 to get 12. So I'm going to times this by 4 as well. It's a 4x. There's only one term, so we're not going to be multiplying, I'm not going to be putting brackets around that. This thing here on the bottom is going to need a times 3. I am going to put brackets around the top one for 3 because there's a 2x and a 1. So what do we do here? Well, I'm going to put this line just to help me to figure out what's the left side and what's the right side. Whoops, there we go. And I'm going to put the equal sign, so equals. And I'll start on the right. Actually, I'll start by doing this. I'll make a bunch of fraction symbols, and all the bottoms are 12. 3 times 4 is 12, 3 times 4 is 12, 2 times 6 is 12. So they're all 12s. Now let's start on the left side and multiply in. 3 times 2x is a 6x. 3 times negative 1 is going to be a negative 3. Then we've got a 4 times 4x, that's going to be a 16x. Then we've got this 6 times 2x, which is a 12x, and a 6 times negative 3, which is a negative 18. I'm just going to put this in red here. Now what I said before still holds true. What I'm going to do, because all the numerators are 12, I'm going to multiply all the denominators are 12. I'm going to put a 12 on the numerator and a 12 on the numerator, and then this can cancel with that. The numerator and denominator are both 12, and then the numerator and both denominators are 12. And so I've taken a question that's got a denominator 4, 3, and 2, and now turned it into something that doesn't have any denominator. I just have the 6x minus 3 minus 16x equals 12x minus 18. After you have got rid of your denominators, then you want to get rid of any brackets. No, there are none. Then you want to make sure that you combine any like terms, and it does actually look like I've got some like terms here. A 6x and a negative 16. 6 and negative 16, if you added them, would be negative 10. There's way more bad than there are good. In fact, there's 10 more. So I'm going to put a negative 10x, and then a minus 3 is equal to 12x minus 18. And just to keep with the same pattern I did when I wrote the 10x minus 3, I wrote the 10x first and then the 3. I did not go negative 3 minus 10x. I like to have the x written on the left-hand side. So that's what you see there. I've just kept with the pattern that I've been doing all along. Now we need to, once you get common or like terms, we need to move the smaller or more negative x. In that case, the negative 10 is smaller than the 12. So to move it, you need to cancel it out. So I'm going to add 10x to both sides. Negative 10 and positive 10 have canceled out, leaving me with just a minus 3. 12 plus 10 is 22x minus 18. And now I've exhausted all of those options. I've gotten rid of the denominator. There are no brackets. I did the like term. I moved over the x. Now it's just backwards BEDMAS. It's a minus 18, so I will add 18 to this. Plus 18 and plus 18, which equals 22x. 18 minus 3 is 15. And then I can divide by 22, divide by 22. That's gone. It looks gross. 22, and those can be gone. So on the right hand side there, I've got an x. On this side, I've got a flip 15 over 22. Now, if I can reduce it, I should, but 15 can be 3, 22 cannot, so I think that's it. I'll box this and just double check that. All right, that looks good. So I'm just going to zoom out here so we can see all three questions so you can make some notes. Remember the steps. Again, I'll say it verbally here for you. You're going to need to get rid of the fraction by getting a common denominator and then multiplying both sides to have a numerator that matches it. So in the question we just did, my numerator was 12 because that matched my denominator. And then I could cancel those out. After that, you need to get rid of any brackets, and there weren't any. We kind of already did. We put brackets here and then multiplied in. So that's usually taken care of. After the brackets, you end up doing any like terms. Turns out that there were some like terms here, the 6 and the negative 16. Then we had to move over the smaller x, or the more negative, which in this case was the negative 10x. We had to add it. And then we had to do backwards BEDMAS, do the addition or subtraction first. So we did the subtraction of 18 by adding 18. And then we did the multiply and divide of the multiply by 22. So we divided by 22. So that is this one right here is a very involved question. It does almost everything. The only thing that's not in it is the bracket part, because there really aren't any brackets to begin with, though we did actually have to make our own brackets when we did B and C actually. But the ones in the previous chapter with the brackets got quite large, so just keep that in mind. And we're going to do all of this again, but with inequalities, so the algebra won't change. This is as hard as the algebra will get, as difficult as it will get. But then the symbol of this equal sign now changes to an inequality. So we'll get on that in the next chapter, the same unit, next chapter.